Welcome to Algebra 1, Topic 28, Division Properties of Exponents. Now this topic is going to be split up into 3 parts, because there are a lot of different parts of division. So we're going to first start off with Quotient of Powers. Now with your foldable, this is where it's folded to look like a pamphlet. So when we fold over the top few flaps, which have all of the kind of fancy schmancy titles on them, and then once you would open it up, that's where the problems would be. So the blank part, that's what you would paste into your notebook. So starting off with Quotient of Powers. For any non-zero number A and any integers m and p, we get a to the m divided by a to the p equals a to the m minus p. So think back when we were doing multiplication and we had the same bases and we are multiplying, we would add the powers. Here, what we're doing is we're subtracting. So we have the same base of a, and we have numbers m and p. So when we see the same base and we're dividing them, we're going to subtract those exponents, subtract them. So here is an example that we have here. G to the third times h to the fifth divided by g h to the second. Now this g in the denominator, we do not see an exponent, so we're going to write a number 1 right there. And when I simplify this, I'm just going to focus on one variable at a time. So we're going to have g to the 3 minus 1 times h to the 5 minus 2. So 3 minus 1 is 2, g squared, and then we have h to the 3 minus 2, which is 3. Now notice here, this is not the same thing as if we were to write gh to the 5th or to the 5th. These are not the same bases, so we cannot add the exponents here. We're just going to keep them separate. This is our answer. If we want to do another example I want to do that's not on the foldable, I'll do it right over here. So if you have space in your foldable, just write it on the side column. Let's do x cubed y to the 4th over x to the 6th y squared. Now here, we're going to separate it. So just look at our x's, just look at our y's. So when we think about 3 minus 6, which number is bigger? Our 6 is bigger. So when we write the answer, when we write the difference between those numbers, I'm going to write it in the part of the fraction that has the bigger number. We're going to get into next negative exponents coming up, but I just wanted to kind of explain that in advance as a little tidbit. So when we have 3 minus 6, that gives us negative 3. But if we want to have that positive, we're just going to keep that 3 in the denominator there, since 6 is our bigger number. For y, we can do y to the 4th divided by y squared. 4 minus 2, since y is our bigger number here, since 4 is our bigger number here and it's in the numerator, we're going to write our answer in the numerator. So 4 minus 2 is 2. So we would get y squared over x to the 3rd. So that's just another side example. We're going to get to that moving forward, but just wanted to kind of, in case we see any examples, that's kind of how our answer should look. We always want to write our final answer with positive exponents, so that's how we would do it for an example like this. Okay, Now, if we open up that flap, these are the problems that would be underneath it. So if we have 5 to the 5th over 5 squared, same basis, and we're dividing, so we're going to subtract our exponents. 5 minus 2 is 3. So 5 cubed. Which, if we wanted to simplify, that's the same thing as 125. Okay, moving on to number 2. M to the 6th over m to the 4th. Same bases here. So we're going to subtract our exponents, so we get m squared. Then we have p to the 5th, n to the 4th, divided by p squared, n. Now this is n raised to the first power. So if we want to rewrite this, we get p, if we just look at our p right here, p to the 5th over p squared, so that's going to give us p to the 5 minus 2, which is p to the 3rd, and then n to the 4 minus 1 is n to the 3rd. And these are both in the numerator right now because our bigger exponents are in the numerator, so when we subtract, that's where our answer is going to be. You do not need to write over a 1, but that's just for a little bit of knowledge there, just for clarification. Okay, a to the 2nd power over a to the 1st power. This is going to be a to the 2 minus 1, or just a to the 1st, or just a. Number 5, x to the 5th, y to the 3rd, over x to the 5th, y squared. Now here, since we have x to the 5th over x to the 5th, these are the same thing. They cancel out and reduce to 1. So we're going to get 1 times, now y to the 3rd divided by y squared, 3 minus 2 gives us y to the 1st. So our answer is just y. Okay, next problem. Sometimes we're going to deal with coefficients. That's okay. Just group them together like we've done before. So if we just look at our coefficients, we have negative 2 divided by 14. Now, which number is bigger? 14. So our solution, our whole number here, since 2 does go into 14, is going to be in our denominator. We can divide our top and bottom by negative 2, and we get 1 over 14 divided by negative 2 is going to be negative 7. Now let's look at our y. So y to the 7th over y to the 5th. 7 minus 5 is going to be y squared. And if we want to write these together, we can rewrite this as negative y squared over 7. So that's kind of like smooshed together. Okay, next one. Sometimes we might get our variables and they're all jumbled up and they're not written in standard form. That's okay. So here we have x to the 1st, y to the 6th over y to the 4th, x to the 1st. Notice how we both have an x to the 1st, so those will reduce to 1. And we'll get y to the 6th over y to the 4th. Since they have the same base of y, we can subtract the exponent. 6 minus 4 is going to be y squared. So we just get y squared. Okay, last one. R to the 7th, n to the 7th, t squared over n to the 3rd, r cubed, t squared. If we notice here, our t variables are the same thing, so they cancel. Our r, we have r to the 7th and r to the 3rd. So 7 minus 3, since we have the same base of r, is going to give us r to the 4th. And then if we have our n, we have n to the 7th, n to the 3rd. So that's going to be n to the 4th. And that's it. Since our t squares cancel. They reduce to 1, I should say. And that is it. Look at my new graphic. Doesn't it look so cool? Oh my gosh. Anyway, thank you for watching. That was part 1 of topic 28, division properties of exponents.